Alright, so in section 3, we're still looking at comparing means of two samples, but this time they are not dependent. They're not a matched pair, they are independent of each other. So, let's read the question. Test whether mean 1 is less than mean 2. Well, they've pretty much told it to us as far as which one it is. Your null is always that they're equal to each other. Your alternative is either given or inferred from the problem. Now, looking at this, obviously the first mean is less than the second mean. But is it statistically significant? So how we're going to do that is we're going to do some analysis on it. We're going to find the p-value, and we're going to do this by going into StatCrunch and doing something similar to what we were doing previously, t-stats, and instead of paired we're going to do two sample with summary. Let's type in our mean, our standard deviation, and our sample size, and then mean, standard deviation, and sample size. Here's something that I want you to uncheck. Now, if you assume that your variances of the two populations are the same, you would check this. But since it doesn't provide us any of that information, we will uncheck that box. We will make sure that our alternative hypothesis is less than. I think we check that over here, that it's less than. And we compute. So I get a p-value of 0.001 if I'm rounding to the thousandths place. And then now we make our conclusion. Since this is less than our alpha, we reject, and there is sufficient evidence. So again, very similar to the previous problems. But again, we have to make sure that we uncheck that pooled variances, only if it tells us that they're equivalent. Let's look at this one. Number 8. A researcher wanted to determine if carpeted rooms contain more bacteria than uncarpeted rooms. The table shows the results for the number of bacteria per cubic foot for both types of rooms. So do the carpeted rooms have more bacteria than uncarpeted? And alpha is 0.05. So again, for this to be done with a normal or with a t-test, we would have to make sure that it looks approximately normal and no crazy outliers. So if we have our data, we could open it up in StatCrunch. We actually have the same number in each. That does not mean it's dependent. These are still independent things. There's nothing linking them to each other. We go to our t-stats, to sample, and with summary. Or actually with data on this one, right? We don't know what the mean and the standard deviation are, so we just say my first one's carpeted, my second one's uncarpeted. We're going to uncheck this box because we don't know if the variances are the same. It did say more than. If carpeted rooms have more bacteria. So we will go with a greater than. The carpeted are greater than the uncarpeted as far as the number of bacteria that they have. And compute. So we have our p-value, we have our test statistic, lots of things. Again, this would have been greater than. Finding our p-value is just 0.138. And then if we compare that to our alpha of 0.05, our p-value is greater, so we do not reject, and there is not significant evidence to to conclude that carpenter rooms have more bacteria. And again, obviously, they had more. Looking at the data, right? They had more on most of them, like that room didn't. That room had more, but not statistically significant more. So, gives you an idea in section 3. So we're dealing with independent samples, and again, we just go to stat, t-stat, 2 sample, 2 sample for section 3, paired for section 2, and for section 1, we're dealing with proportion stats, 2 sample.